right, good morning, ladies and gentlemen. Let's play with balloons. All right, so we have a balloon here, ping pong ball, and some shredded piece of paper as big as a Tic Tac. Okay, I'm gonna pick up the balloon, I'm gonna rub it on my shirt here. And can I touch the balloon? Oh. Oh.
Okay, how
is it moving? Hey, come over here, come over here. All right. Uh-oh. Ah! Get over here. Okay. Ooh, now we're gonna stand still. What is going on here? It's stuck on the tape over there. Get over here.
So there's a force being exerted between the balloon and the ping pong ball. It's obvious.
Yes.
Now, let's do this. We've got these little pieces of paper here.
Yeah, so we've got these pieces of paper over here, and oh.
Some of them jump off, and then,
Oh, whoa,
then
do you
they
see that?
jump back down. What the heck is going on here?
Oh, wow. Okay, so some of them just fall right off.
Yeah.
Like those, yeah. See if I can get a few of them to fall off here.
Now, if you were in class, we'd give you balloons and let you play with this yourself, but...
Yeah, so look how some of them just fall off. Okay, get them all on there, and then some of them just...
Jump off.
Yeah, they just fall off like that. Okay. All right, so what is going on here? All right, so a model. A model is an explanation that attempts to reveal the workings of nature.
Yep. And we need to develop a model for what we just saw with the balloon, the ping pong ball, and the little pieces of paper.
Yeah, what is going on here? Let's see if we can figure out how to model it. All matter has a fundamental electrical nature called electric charge.
All matter is electrical in nature.
So we all got a charge, even me and you, Mr. Boykin.
Yeah.
Electrical charges exert forces on other charges.
Yep, that's the bottom line. And this drives just about everything that's going on around us.
These forces are exerted at a distance without direct contact.
What the?
So that's what we saw over there, right? With the ping pong ball, right? There was an attractive force there. The ping pong ball was attracted to the balloon, but there was no touching.
Right. And so this is an issue. How can forces be exerted without direct contact? And science doesn't like this kind of stuff. There has to be an explanation.
So this should be some review for you. We've got the atom part, proton, neutron, and electron, which you guys have heard before. Our proton has a +1 charge, neutron is neutral, no charge, and electron has a -1 charge.
I think they should copy this thing down in your notes.
Yes,
It's 1, 2, 3, 4, 5, 6 vertical columns and 4 horizontal rows. So get this information now. Now that mass is less important than this other stuff.
Location, nucleus, these are both the nucleus, this is outside the nucleus, but can it be removed? And the only one that can be removed is my electron.
The electron.
Right.
Yeah, to get things out of the nucleus requires incredibly high energies, and you don't encounter that in nature.
And so these are the main two columns you need to understand.
All right.
Okay. Normal atoms are neutral and have the same number of protons and electrons.
And if you've had chemistry, you know this already, yes?
They cancel each other out. You've got, so one positive charge, it cancels out one negative charge. So a positive plus a negative, we get 0.
Yep.
Only electrons can be removed from atoms. We just saw that, right? It's the only one that can be removed.
And so the model that we've got here for the balloon was that electrons were being rubbed from her shirt onto the balloon. And so what does that do to the balloon? What does that do to the shirt?
Well, okay, let me go back here actually, so we can talk about that. So if electrons are gonna be removed, make sure that's kind of next. If electrons are removed from me and I'm neutral, now I become...
You're missing electrons.
Right, become positively charged,
That's right.
Now the electrons are on the balloon, we've got more electrons than there originally were, So now the balloon is negative.
Yep.
Right, and so this idea of charge is super important in transfer of electrons specifically.
Yep.
Okay, protons don't move.
No.
Okay. Conservation of charge. Just like, conservation of energy and momentum, there is a constant net charge in an isolated system. It remains constant.
So the system would be Ms. Moore and the balloon, and the charge before and after she rubbed it on her shirt remains the same.
Yeah, so even though electrons are being transferred from here and this is negative and I'm not positive,
Yeah.
overall there's still the charge is conserved. Okay.
She just put that balloon on the wall. Witchcraft!
All right. Electrons, negative, and protons, positive, in case you forgot, have opposite charges, and they will create an attractive force.
This is what holds atoms together.
If they have the same charges, then you have a repulsive force. I think I've got an image here. A repulsive. So opposite charges are attracting, and then like charges, both positive, negative, they repel.
Yep.
Okay. A conductor allows electrons to move around freely.
Yep.
Metals are conductors.
Yeah.
Yeah, okay. And an insulator doesn't let them move around. They are stuck in that balloon.
Yeah, a balloon is an insulator. She put the electrons on that balloon, and they stayed right where she put them.
And should we like?
Yeah, show them. She got a little face on here. She put the electrons on the other side.
Yeah, the electrons are over there, and so when I move this over here, that side, there's no electrons over here, right? So when I move it over there to try to stick there, it
starts to fall because there's no electrons there, and then it whips around and hooks back up with
all
the
the electrons are right there, and that's where they're staying. Okay, and I moved this slide here because balloons are made of rubber. That's an insulator, and so you've got glass, plastic, air, wood, fiberglass, asphalt, and then over here, of course, we have our metals, right? Copper, gold, iron, all this stuff.
An interesting thing there is all these are metal, graphite, and concrete. So graphite's the stuff that's in pencils that will conduct electricity, and concrete will conduct electricity.
Dang, don't want to be on the sidewalk.
No.
Okay, that does not seem like a very smart.
And here's a wire, and a wire has got two parts. It's got the metallic conductor in the middle, and it's surrounded by an insulator, so that the charge stays where it is.
Yeah, I forgot about
Won't go through that.
Okay, when two different insulators are rubbed together, electrons can be transferred if they have different electron affinities.
So for example, the hair is an insulator and the balloon's an insulator, but the balloon has a greater affinity for electrons than the hair.
Yeah, and so the electrons from here are going to hop over there.
That's right.
Okay, when we say electron affinity, we just mean that they're more drawn over to the balloon.
Yeah. The attraction for electrons is stronger.
Yeah. Static electricity. When an electron is placed on an insulator, it stays where it is. Exhibit A.
Right there.
Right, those electrons are right there and they're staying right there.
Yeah. And static,
this one.
and static means stationary, not
Yeah.
moving.
This one looks like it's going to give away any second now. It's kind of losing its oomph. Okay.
Whoa!
Whoa! How the heck? So this kid is, oh my gosh, I mean, I remember the good old days, sliding down the slide, and I loved it, but I hated it because then your hair does this, then you get all, and it like shocks you.
Yeah.
So what is going on here? I think we're going to answer this in our next video.
Well, the hair, the kid is charged because you've got and I'm not sure if it's positively or negatively charged, but what happens is they all have the same charge, and so they're trying to get away from each other as far as possible.
Where do they get the charge from?
Well, you've got the plastic slide,
Oh,
and then
when
the
he's rubbing on the
clothes, and it's just
slide?
like rubbing a balloon on clothing, and so charge is transferred from one to the other. And then when you get off and you get a shock, that's because the charge is going back to where it started. And we'll talk more about that in a minute.
Yeah, we're going to get more to it, okay? So what we want you guys to do now is you're going to go to the video below, and you are going to go ahead and watch that video. As you watch the video, you're going to do the video guide as you go along.
All right, it's simple. Have fun.